Myles. Do you need to?
Yeah. It's in. I'm making noises.
So hello, my name's Myles. I'm part of a group called ActuatedLab, which is just a fancy name for me and my best friend who have a workshop together, and we like to make sort of electronics-based artworks and do various projects involving microcontrollers and more recently architectural pieces, interactive architectural pieces which are based with electronics. So earlier this year I did a piece in Arcade Cardiff which was called Columns, which was, like I said, an interactive architectural space that took quite a while to work on, and it involved various things like microcontrollers, Arduinos, linear actuators, a lot of mechanics and architecture came into it. I'll just show you a little video of it, just so it gives you a little background of what it actually was. So, So I'll just talk over it because it's so the screen you see here is the sort of pure data feed which we were using to generate the sound, which is generated when somebody comes into contact with one of those copper pads that you'll see. So what you're seeing now is a motor which is attached to this piece of threaded rod which runs the entire length of the beam, which slowly moves each column from right to left, left to right. When it hits one end of the beam, it'll start moving back to the other end thanks to a limit switch. So when somebody touches the copper pads, it generates the sound on pure data, which wasn't just a sound clip, they're actually generated depending on the length of the press and also how many times it was pressed in a certain space of time, like a second. And when you actually touch the copper pad as well as generating sound, it would also stop the motors at the top, so the actual column itself would stop moving. So the actual idea behind the whole exhibition was that when we first started it, all of the columns were started on the looking down the right hand side, and if nobody ever went into the exhibition, they'd all move in unison from right to left, left to right, right to left. And as soon as people start coming in and actually interacting with them, they've actually changed, they've staggered the actual shape of the space. And also sonically, they actually change the way that it actually sounds. So yeah, that's what I did. You can see here that we made it was quite budget constricted, and we only had a very small amount of money to make it. So wood wasn't actually a design choice, it was more of a budgetary concern that we had to work within. Ideally we would have made all the sort of beams out of metal, because when you're working with bearings and linear actuators, they don't really like to be put on something which is a little bit skewish. They really like to be dead straight. So you can actually see that the beams themselves were a little bit bowed, so that had a few challenges in actually making the motors be able to propel them all the way along the actual length of the beam. So it's my crude couplings made with a hose clamp and a zip tie for the thread rod, because machine couplings are actually incredibly expensive, especially if you want them in a non-standard format. So if you want sort of 12mm rod to 5mm shaft. It really costs a lot of money. This is Rachel, having a great time. So yeah, the show took a lot longer to set up than I initially planned. When I originally envisioned this exhibition, I wanted to have everything laser cut, so everything was, dead straight. You knew everything was, all the holes were going to be in the right places. But when I got a quote for the laser cutting from a company in London, as you said earlier, it was about £200 per sheet of MDF, which was, when I was using about 12 sheets, was incredibly expensive. So I decided to actually cut it all with a friend of mine by hand, and that again led to just taking forever and ever and ever, because you never really, when you think about it in your head that you're I'm gonna cut some bits of wood out, I'm gonna drill some holes in them. But then when it actually comes to drilling the holes, you need to have all the holes in the exact same place on each plank. It'll take an entire day or longer, and the same goes for just all the aspects of it. Just were a bit of a complete nightmare. But I've recently built a CNC machine, which is a sort of computer-opted cutting machine, which I'm going to be doing all my cutting on from now on, and I should be expanding it very soon to be about 2.5 meters by 1 meter long. So this would have taken no time at all. So yeah, these are the copper pads, and the way that I was able to register as somebody touching them was by way of capacitance sensing. So on the inside of each one of these columns there's a little circuit board with an AT Tiny on it, and a battery pack, and there's a little probe which runs to the copper pad via the screw that's screwed in on one of the sides. And what it's doing is that little wire is attached to 2 pins on the AT Tiny, which are basically sending pulses of electricity, and it's measuring the time it takes for the pulse to go back. And anything organic that's alive has got a sort of natural capacitance to it. So when you interfere with it, you can actually register some sort of disruption in the average that it's already got. So you're able to get quite large ranges actually from it. You can actually get sort of a meter and a half range from any piece of metal. But when you're doing multiples of them, so if you have a lot of them in the same room, they tend to interfere with each other. And even having them plugged into the same socket, or the main socket, they can be completely thrown out of whack, and they'll just start going off when somebody walks past the shop, or they'll just, once somebody's touched them, they won't stop registering for hours. So that was quite challenging as well. So I made all the circuit boards myself using etching process with ferric chloride, which I just got a little bit of footage of here. It's really, really good. So the main board that did all the computational sort of task was an Arduino Mega, because we needed a lot of outputs to drive the sort of 8-stepper motors. So yeah, for this we had to design our own sort of shield for it. So what we do is we design the board on a piece of software that we use called Fritzing, which is a lot like Eagle, but a lot less horrendous to use. So once you design it, you print it off mirrored onto a piece of acetate from a laser printer. And laser printing ink isn't actually an ink, it's actually a plastic. So when you heat it up on the face of copper with an iron, it'll transfer off from the acetate onto the copper. So then what you do is you bathe the copper in ferric chloride, which will slowly dissolve all the copper into an aqueous solution, but except for everything that's under that black plastic track. So everything that's under there, which are your circuit traces, is generally okay. So then once you've finished acid etching them, you then rub off the black mark with some sort of acetone, or nail varnish remover works really, really well. And then you have your circuit board, and then you just have to drill it with a drill press, and then you end up with what can be some really nice circuit boards. This one in particular actually had a bunch of mistakes on it that I only realised very close to opening the exhibition, so I had to go through and make it a lot less pretty by just routing actual wires through it. So you can see there, just rubbing it all off. So yeah, we're going to go back and do another exhibition in October, which is a similar sort of theme of architectural big spaces, and employs the same sort of techniques we've used here. This is just my mate Pete, who did all the sort of hard graft carpentry wise. So yeah, any questions?
Sorry, quick one, I'm sorry if I missed it. When you were showing the speed of the film, the installation, were those beams moving by themselves? Did you have notice on them? Or was that just the interaction of people touching them?
No, there's, I'll try and find a better picture. If you look, so at the top of each of the beams, the beams that ran across the room, there's this threaded rod. So, and this threaded rod is attached to a motor, so the threaded rod is spinning, and then on the threaded rod is a nut, which is secured to each of the columns. So, when you think about if you're screwing on a nut, the nut will move down the threaded rod. So, if you move the threaded rod, or the bulb that you've got.
You caused that, sorry, that's...
Yeah, it was all on motors.
What kind of reactions did you get from the people that came and tried it out?
A lot of people were really concerned that they weren't moving, which was fair enough because they were in fact moving really, really slowly. We did mess with them moving quite quickly, but as I mentioned with the beams, that they weren't quite true because they weren't made out of metal and they were made out of wood. A couple of the columns they would bend quite a lot towards the middle, so the column would happily progress at a nice speed going down one side, and then at various spots on the other way up they would have a real bit of trouble and the motor might get really hot or it might stop altogether. So I brought the speed down quite a lot just to make sure none of them had any problems. And in doing that, they became really, really quite slow. But I really quite like it because it's a really sort of persistent sort of thing. You can go in there and you can be in there for sort of 10 minutes and not really be aware that they're moving. But if you look at one and then you don't look at it for a while, or you don't look at the room and you look back, you notice that the room's a completely different shape than it was a little bit before. But yeah, people really quite liked engaging with it. They were quite eager. You have to be careful when you have an interactive exhibition. There's all these you have to try and gauge just how much people are going to poke your piece of work, and you have to be careful about they're going to pull things out. But nobody did anything too dramatic. So yeah.
How did you find it working in this shopping center sort of environment?
I got some money from the Arts Council. I really liked the idea that it was in a shopping centre. It was a really public space, so people were going to be exposed to it, even if they wouldn't necessarily go into that shopping centre to say, "Oh, I'm going to go and have a look at an art gallery," but it's there, and it's people that walk past that space, and the thing that they would tend to do is they sort of walk past the shopping. They just walk really slowly, like that, and then as they go past the wall, they just go. Carry on. Sometimes they come in. You would have to quite regular, just shoppers. You would sometimes just have to they'd stop for age, and you just sort of have to approach them. Would you like to come in and have a look? And they were like, oh, okay. And you get the odd person who goes, "What's this for?" And then but it's really interesting because if you're ready to engage people about it, they are often really, really happy to just chat about it. So it's really nice having a piece of work in such a space where people would go and they would encounter something like this that they were not banking on encountering. And it's really nice. I think it's really good to have a public space like that to do probably quite experimental work.
I didn't quite catch what you called. You said said that you had something attached to the copper plate, and you said that the word a few times, but I couldn't hear what you were saying.
So I had an 80 tiny, which is
An what
an
type?
80 tiny.
An 80 tiny.
Yeah.
Okay.
ATTINY, which is a really small microcontroller. So it's a basic little chip that you can program to take an input, do some processing, send an output. It was running the Arduino bootloader, so all the code that I wrote was in Arduino. The other bit of code, which was for the sound, was in pure data. I mean, the 80 Tinys are just really amazing. You can get so much for such a small amount of money. There's a whole bunch of libraries as well that work on them, and they're amazing.
How did you get the concept?
As I mentioned really briefly, I've made a CNC machine. So that's basically a big drill on a couple of gantries, which do this, that, and it can also move up and down. A lot of the mechanisms for a CNC machine involve something called a lead screw, which is pretty much that threaded rod. When I was putting together my CNC machine, I had a piece of threaded rod, and for whatever reason I decided to put it in the end of the drill, and then I put the nut on it, and I was just spinning it on the drill. And then I was noticing how the nut would run up and down the piece of threaded rod. And even if you're making a machine like that and you see that mechanism in action, you don't necessarily really engage with that mechanism. But just by faffing around with it, for no good reason, I saw it in a different light, and then I came up with a bunch of pieces really, using that mechanism. And this piece came at the end of a sort of exploration of that mechanism. And ever since that, I've gotten a lot more into mechanics, so gears, all different kinds of mechanisms, and for working those into sculptural and architectural pieces. So yeah.
Did you record the interaction, like how, did you get a record of how the columns moved over the period of time?
Yeah, I don't know if you saw quite at the end there. We took a couple of time lapses actually of the actual thing in action. So just at the end, if it's going to come on.
It's coming.
It's coming. So if you look, so this is sped up somewhat, but just in a second when the sort of credits come in, is a sort of, I think, about 4-hour period that I took of time lapse of taking a picture every 30 seconds for 3 hours. And you see there just how much they move.
So it take about an hour for them to do a return run?
Yeah.
Okay.
But I would have liked to have taken a lot longer time lapse, but at the time I was incredibly stressed. And it didn't really occur to me then.
Yeah, documentation is
It's just get it working and then everything else goes out the window.
You said you're doing another one, are you doing it with the Arts Council again?
Potentially. I will try and do some more work with the Arts Council. I'm not sure though yet. I haven't actually applied for any funding yet.
Is it in Arcade Cardiff?
Yeah, if he's still there, it's going to be there in about October.
I can come back to Dorkbot and advertise.
Yeah.
Plug in store.
Was it part of some event that you applied to do part of?
No, I applied as an individual for a small grant. So I'll tell you the figures. So everything that was built there was built for just a little under £800. So it was pretty cheap actually, I think. And I mean, there was more money that we were given to pay. So I paid myself, I paid my friend Mike, who's the other part of ActuatedLab, I paid the guy who owns the space, because at the time he was running that space pretty much entirely off his own back. So he's paying a lot of outgoings for it, he was pouring his life into it, so I was pretty happy to give him some money for that. And I paid John, so it was nice to pay everybody, and then so the end parts came actually to the smaller sum.
Are you going to do something similar if you get it next time?
Yeah, if I get it next time, it's going to be with the guy who owns that space. If he's still in that space, I may use that space. He's also got another one adjacent, which is slightly different format. It's not quite as long and it's different. It's quite short and wide, but I'm working on the mechanism now for the next one, and I've just about got that finished. So now it's just sort of working on everything else.
So you found the space, the art council didn't?
No, the Arts Council don't really prescribe you anything. If you can imagine the Arts Council, they're very hands-on.
Yeah.
They like, you have to do all the work basically, and then they'll just...
Have you been to this space, the Arcade Cardiff? Do you know the Arcade Cardiff, this space, the exhibition? So it is like a fast run. I think they do about two exhibitions per month between the two spaces.
I see.
So it's quite good, they are really approachable as well. So if you have a project, that's really interesting. You just go knock on their door and see what they say.
Yeah, the guy designed everything as well, as I designed it to be quite modular, so that everything was bolt through. I tried to use as few screws as possible so that I could reuse things. So that was the idea of going that, so almost like a sort of flat pack exhibition almost. Everything was numbered, everything was laid out, so it was very easy. Once everything was cut and made, it was very easy to get it up. And really, really easy to take down. So I've still got everything, but again, if I were to make it again, I'd make all of those beams out of metal, so square metal tubing, and I'd use some aluminium extrusion for the runners. I mean, I've got a picture of the runners that I made, which I was really proud of because they did the job, but they were pretty horrible. Let's have a look.
Have you looked at strengthening the beams that you have, or putting some sort of support in to stop them from bowing?
We did try that, because we weren't... the way the shape is shaped actually sort of cones and funnels down to it's wider at the front and it's a lot thinner at the back. So the ones at the back were actually pretty good. It was the ones at the front edge which were the ones that were in trouble. I think this is actually a picture of the one we actually strengthened. We basically, so where you see you've got the sort of 2x4 bit, and then we've got the runners that I made out of varying thickness of MDF. We bolted through another bit through the thing, which helps a little bit. But yeah, metal is fantastic.
Last thing, are you a programmer by training? Is that what you started off doing?
I studied a course called Interactive Media at Newport, which means very little. One of the virtues of the course was that it was really, really open. It led to a lot of people's downfall because you pretty much weren't taught a skill set. But so I was sort of left alone. A lot of people were happy making pretty mediocre websites. But I decided that because it was so open, I could pretty much do whatever I wanted, so I just started doing electronics and programming, which is, thanks to the internet, pretty easy to get into. Yeah.
Right, thanks, Myles.
Actually, where can we get hold of that acid?
Ferric chloride is pretty much buy from Rapid Online. It's not particularly harmful. There are no gases emitted from it because it's all that kind of solution. There's loads of information on the internet about it.
That was something really impressive about it as well.
It looks cool, doesn't it?
Seeing that off the